Hello everyone, we are Group 2. Today we are going to have our presentation. We have total 5 questions. I'm Norman Jiao Yiwei. I'm in charge of question Mock 4, question 2, part A. Then let's move to my question. For my part, the question is, Paul has prepared 5 questions in descriptive statistics, 10 questions in probability, and 12 questions in probability distributions. From these prepared questions, 9 will be selected randomly for the quiz of statistics that will be held next week. What is the probability that the quiz will consist of 2 questions in descriptive statistics, 4 questions in probability, and 3 questions in probability distribution? From the question, we can get some information. The question needs us to find the probability of selecting some specific questions. The question needs us to collect of 9 questions from total 27 questions in any selections. And the order does not count. So this question belongs to a type of combination. According to our lecture notes, the combination formula is listed below for your reference. N choose R equals to factorial of N over factorial of R times N minus factorial of N minus R. So the total number of ways of selecting 9 questions from 27 is 27 choose 9. After calculation, the answer is 4686825. The number of ways of selecting 2 questions in descriptive statistics is 5 choose 2 equals 10. The number of ways of selecting 4 questions in probability is 10 choose 4 equals 210. Number of ways of selecting 3 questions in probability distribution is 12 choose 3 equals to 220. So the total number of ways of selecting specific 2 questions in descriptive statistics, 4 questions in probability, and 3 questions in probability distribution is 10 times 210 times 220. The number of ways of selecting 2 questions from 27 is 4686825. So the final answer is 10 times 210 times 220 over 4686825. The final answer is 560 over 5681. This is the end of my part. Then let's move to the next part.
Hello, my name is Chichi Kin, and I'm now going to talk about Mock 4, question 2. Before we try to solve the question 2b, part 1, we need to recall 2 formulas that we learned from the lecture. The first formula is probability B given A is equals to probability A and B divided by probability A. The second formula is probability A or B is equals to probability A plus probability B minus probability A and B. Let's look at the background information of the question. A survey is conducted to study the customer behavior of a convenience store. It is found that 70% of the customers patronize the convenience store every day. 56% of the customers purchase newspapers. For those customers who patronize the convenience store every day, 75% purchase newspapers. We can see that there are 3 figures from the background information. Let's do a summary of the figures. First, let A be the event of customers patronize the convenience store every day. Let B be the event of customers purchase newspaper. And according to the background information, probability A is equals to 0.7. Probability B is equals to 0.56. And the background information states that 75% of customers purchase newspaper, given that the customers patronize the convenience store every day. That means the probability B given A is equals to 0.75. Do you remember the formula one that I mentioned in the beginning? At the beginning, we can rewrite probability B given A into probability A and B divided by probability A. And we know that the probability A is equals to 0.7. So we can know that probability A and B is equals to 0.75 times 0.7, and it is equals to 0.525. Now let's look at the question. The question requires us to calculate the probability that a randomly selected customers neither patronize the convenience store every day nor purchase newspapers. In other words, the required probability is probability not A and not B. Using the complementary rule, we can rewrite probability not A and not B into 1 minus probability A or B. And now we can use the formula 2 that I mentioned at the beginning. We can rewrite probability A or B into probability A plus probability B minus probability A and B. And we know that probability A is equals to 0.7, probability B is equals to 0.56, probability A and B is equals to 0.525. And we can easily get the answer 0.265 for question 2B part 1. That's the end of my presentation. Thank you.
Everyone, my name is Tamuho Michael. So let's move on to the part B2. The question of this part is that given that a customer purchases the newspapers, what is the probability that this customer patronizes the convenience store every day? As we know, when the question has the term of given that, we can determine it as the conditional probability. So, in this question, I will let A be the event that the customer patronizes the convenience store every day, and let B be the event that a customer purchases the newspapers. From this question, we can understand the probability that the customer patronizes the convenience store every day is 0.7. At the same time, the probability that a customer purchases the newspapers is 0.56. Also, given that the customer patronizes the convenience store every day, the probability that they purchase the newspaper is 0.75. As a result, the probability that the events A and B both occur is 0.7 times 0.75, so is equal to 0.525. For the conditional probability, there is a formula. The probability will be equal to the probability that the events A and B both occur over the probability that only the event B occurs. Accordingly, the required probability is equal to 0.525 over 0.56. So we can get the final answer is 0.9375. As a result, the probability that this customer patronizes the convenience store every day is 0.9375. Thank you.
So, good evening, I'm Wong Taek-yoon with student ID 160705889D. So today I'm going to talk about question number 2B and the third part of this question. So from the previous two parts, we have got the followings, like probability of A equals to 0.7, probability of B equals to 0.56. So I'm going to talk a bit of that, like probability of A means those who patronize convenience store every day, while B means those who purchase newspaper. But it doesn't mean that it is among all customers who go to the convenience store every day. It's among the whole pool, okay? So probability of B given A means the exact thing I just mentioned, which is among those who patronize convenience store every day, the percentage of people who buy newspaper, okay, 0.75. So in the third part of this question, we have to find the probability that the customer purchase newspaper given the customer does not patronize the convenience store every day. So we have probability of B given A bar. A bar means not going to convenience store every day. Well, we can convert it in this way: 1 minus probability of B bar given A bar, which equals to this thing, like 1 minus probability of A bar and B bar divided by probability of A bar. So to continue, the upper part can be converted into 1 minus probability of A or B, okay, and then divided by 0.3. 0.3 means probability of A bar here, and we can finally get this, like 1 minus 1.26 minus 0.525, probability of A plus probability of B equals to 1.26, while this part, probability of A and B, equals to 0.525. Like here, we've got this in the upper parts. So the whole thing divided by 0.3 and then 1 minus the whole thing. We've got the final answer, 0.1167. Thank you.
Okay, thank you, my teammates. I'm Henry. Then I will introduce the last question. First of all, let me introduce the last question. Mock 1, Question 2, Part B. 3 members of a private country club have been nominated for the office of president. The probabilities that Mr. Chen, Mr. Li, and Mr. Chung will be elected are 0.3, 0.5, and 0.2 respectively. Should Mr. Chen, Mr. Li, or Mr. Chung be elected, the probabilities for an increase in membership fees are 0.8, 0.1, and 0.4, respectively. If someone is considering joining the club but delays his decision for several weeks, only to find that the fees have been increased, what is the probability that Mr. Chung was elected president of the club? Then let me highlight some key numbers. The probability for Mr. Chen, Mr. Li, Mr. Chung to be elected as president are 0.3, 0.5, and 0.2. And we also know if Mr. Chen, Mr. Li, or Mr. Chung be elected, the probabilities for them to increase the membership fees are 0.8, 0.1, and 0.4. Now, someone only knows the membership fees have been increased, but he didn't know who will be the president. So, the question asks us to answer the probabilities that Mr. Chung was elected president of the club. It seems that this question focuses on conditional probability. So, then I will analyze this question. Now, I will answer this question. First, let event A be fees increase, and event B1 be Mr. Chen was elected, event B2 be Mr. Li was elected, and event B3 be Mr. Chung was elected. And from the slide 1, we can know the blue numbers. The probabilities for Mr. Chen was elected, that probability for event B1 is 0.3, and the probability for event B2 is 0.5, and the probabilities for event B3 is 0.2. And also from slide 1, we know that the green number, if Mr. Chen or Mr. Li, Mr. Chun be elected, the probabilities for an increase in membership fees are 0.8, 0.1, and 0.4. From our textbook, we know that the conditional probability of event A given event B can be denoted by this sample. So, if given event B1, Mr. Chen was elected, the probabilities for event A phase increase can be denoted as this sample. So, from the question, we know that the probability for event A given event B1 is 0.8. The probability for event A given event B2 is 0.1, and the probability for event A given event B3 is 0.4. So we turn to slide 1. The questions ask us to answer the probabilities for Mr. Chen was elected as the president, given that the fees have been increased. So this event is A, this event is B3. Given A to calculate the probabilities for B3, we can denote it as P B3 given A. And also, this is the question, this is the answer of this question. So, how to calculate the probabilities for B3 given event A? We can use Bayes' theorem. This is definition of Bayes' theorem. If event B1, B2, or and to BK are mutually exclusive events, such as that B1 and B2, 2, and BK contains all samples points of S, then for any event A of S with probability for event A don't equals 0. So the probability for event Bi given event A can be denoted as this equation. And the I can be 1, 2, 3 until K. Then I will calculate the probability for event B3 given event A through the Bayes' theorem. In these questions, there are 3 events, so the K equals 3. And we need to calculate the probability for event B3 given event A. So the I equals 3. Then we can use Bayes' theorem. Probability for event B3 times probability for event A given event B3 divided by probability for B1 times probability for event A given event B1 plus probability for event B2 times probability for event A given event B2. And then the probability for B3 times probability for event A given event B3. Because K equals 3, so we have done the Bayes' theorem. Then we can use the number in Slide 2 to calculate the final answer. Okay, I will calculate it. First, the probability for B event B3 is 0.2 times probability for event A given event B3, 0.4, divide probability for event B1, 0.3 times probability for event A given event B1, 0.8 plus probability for event B2, 0.5 times probability for event A given event B2, 0.1 plus the probability for event B3, 0.2 times probability for event A given event B3, 0.4. So now it's easy to calculate the final probability. Use calculator 0.2162. So that's the probability for Mr. Chun to be elected as president given membership fees have been increased. The probability is 0.2162, and that's the final answer. That's all of Group 2 presentation. Thank you for watching.